Hello again, everybody. We're going to finish up these 10.5 notes. We started with permutations yesterday where order mattered. Today we're going to talk about combinations where order does not matter. And this also means that repeats are not necessary. So what I mean by that is if we talk about the possible combinations of two letters that we choose from the list of A, B, C, D. So we have two letters. So let's say I pick A first and B second, and then another time I pick B first and A second. Well, if it doesn't matter which one I pick first or second, just that I pick those two and they are going in a group, then their order doesn't matter, and that technically is repeating the A with the B, just in a different order. And so that's what we're talking about. Order does not matter. There is a formula for combinations. It looks very similar to our permutation formula. It just has this extra r factorial at the end. So we're ordering a sandwich at a restaurant. You can choose two sides from a list of 8. How many combinations are possible? The order doesn't matter there, because if I pick French fries and nachos, or nachos and then French fries, I'm still going to have nachos and French fries as sides with my sandwich. So the order I pick them in doesn't matter, because I'll still get those two. So we have 8 total to pick from, and we are choosing 2. So that's 8 factorial over 8 minus 2 factorial times 2 factorial. Now just remember, when you're plugging this into your calculator, if you're doing it exactly how you see it, not subtracting the 8 and the 2 to make it 6, make sure that you put an extra set of parentheses regardless. So that way it does all of the factorials on the bottom before dividing it from the 8 factorial, because you will get a different answer from that. And so I do all that great math and I end up with 28. There are 28 possible combinations without repeats of the two sides out of the 8 that are possible. You're listening to music. You have time to hear only 3 songs from your playlist of 16 songs. So I have 16 to pick from, and I'm going to hear 3. Now again, it doesn't matter what order I hear those 3 songs in. I just want to hear those 3 songs. So we have 16 factorial over 16 minus 3 factorial times 3 factorial. I do all of that math, and there are 560 ways that we can combine the 3 songs out of those 16 for us to listen to. Now, when we get into class tomorrow, we're also going to talk about Pascal's triangle, which is another way for us to determine combinations, especially if we're not able to have a calculator, or if for some reason we have a very basic calculator that doesn't have these factorial buttons. So remember to ask me about Pascal's triangle in class tomorrow. Besides that, this is it. Have a great night.